Okay, we have already discussed the normal distribution and the uniform distribution. So now we go to the next important distribution. That will be the exponential distribution. For the exponential distribution, the main idea is we consider the process of customers arriving at a restaurant. There are the two different variables. That will be the how many people will be show up in a given period of time, or how many minutes between two customers. We are talking about how many customers arrive during 1 hour or half an hour. That will be the Poisson distribution we have already discussed. We are talking about the discrete probability distribution. So now we focus on the second way to describe this process. That one we will call them the exponential distribution. For the exponential distribution, we are focused on the time between two customer arrives. So this is a time, so it could be any value. So x is a continuous and has an exponential distribution. When we are talking about distribution, there are the two things we are interested in. First one will be the parameters, and the second one will be the probability density function and the cumulative distribution function. For the uniform distribution, there are the two parameters, the lower limit and the upper limit. For the normal distribution, there are the two parameters. That will be the population mean and the population standard deviation. For the exponential distribution, there are only one parameter. That will be the average or the mean arrival rate per unit of time or space. That is exactly same to the Poisson mean, but actually these two distributions they are related to each other very close. That is for the parameter, and for the PDF, this is the function, and this is the function for the CDF, the cumulative distribution function. What is the meaning for the exponential distribution? We are interested in the how many times we suppend for the next event happened. So in here, given the minute, how many minutes for the next event happened, the red tail area will be equal to the the power of the negative lambda x. So you can see when the x increased, becoming to bigger and bigger and bigger, you can see this area is becoming to the smaller. So for the probability of the continuous variable, the probability is the area. So which means when the x increased, the probability will be decreased. So for the exponential probability function, they will be go to the 0 if x increase. And this is a very skewed distribution. And in the exponential model, the focus is on the waiting time until the next event happened. For the left tail exponential area, that is we focus on how many minutes we have to suppend for the next event happened. So that will be the minute smaller than some value. This is an example to show you how to use the exponential distribution. If the mean arrival rate is 2.2 calls per minute, we want to have the 90% for the waiting time, the top 10% of the waiting time. So what is how many minutes we have to suppend? For the exponential, the negative lambda x equal to the 0.10. So we take the log for each side. We will get the negative lambda x equal to the log 0.10. And we move the lambda to the right hand side. And finally, we will get the 1.0466 minutes. So the lambda equal to the 2.2. We put the 2.2 into this equation. You can see this is for the E. we can take the log, and then we can move out the e, and we have the value of the lambda. Finally, we can find the value of the x. So what is the meaning for this 1.0466 minutes? It means 90% of the calls will arrive within 1.0466 minutes. Or we can change them to the seconds. That will be the 62.8 seconds. We also define the mean time between events. We call them the MTBE, is the exponential waiting times. So in other words, we have this relationship between the MTBE and the 1 divided by the lambda. For the mean time between events, the average time between the two events equal to the 1 divided by the lambda. What is the lambda? Lambda is the average arrival rate per unit of time or space. In this example, it will be the 2.2 calls per minute. So now if we use 1 divided by 2.2 calls per minute, we will get the average time between the two events. Actually, that makes sense. So the 1 divided by the lambda equal to the mean time between two events. That will be the unit of time. Or we can use 1 divided by the MTBE. That will be equal to the lambda. What is the lambda? Will be the average events per unit of time. That will become to the how many events happened. In this example, will be the 2.2 calls. So that is the main idea for the mean time between events. Finally, this example to show you how to use the exponential distribution. There is a company, they provide some products that will be the flight panel display, and they are using them in the airplane. So currently we found the MTBF. The mean between fails will be the 22,500 flight hours. And what is the probability of a fail within the next 10,000 flight hours? Because we already get the MTBF. So what we want to do is we want to find the lambda. What we should do is we use 1 divided by MTBF. Because this is between events, so this is the MTBE. But in this question, they define them to as the between the fails. So actually they are the same idea. The lambda will be equal to this value. And for the x is smaller than the 10,000, will be the 1 minus this part. The lambda will be equal to this value, and the x is 10,000. So we sum them together. So this value times the 10,000, we will get the 1 minus e negative 0.4444. If you put this value into your calculator, you will get 0.64 will be equal to the 0.35 and 88. What is the meaning for the 3588? This is the equation in here, and for this equation they gave us the area. This area equal to the probability. So for this example, 0.3588 will be the probability or the chance of the fail within the next 10,000 hours of flight. And this assumes that the fails follow the Poisson model. So now there is another thing I want to mention. In here, this is the capital X is bigger than the small x, and this capital X smaller or equal to the x. You may ask a question to see, can we have the x is bigger or smaller than the small x? But actually, they have the same meaning. The reason is like we have already discussed at the beginning of this chapter. A single point has no probability. So which means bigger than the small x or bigger or equal to the small x, they will give you the same value. And you can find several examples and questions in the textbook. So please carefully go through the examples and do several questions and before you attend the tutorial. Thank you.